Why hello Algebra 2 students, this is lesson 60. Our objective for today is how do you solve direct and inverse variation problems. Yes, that's what it says even if you can't read my handwriting. This is just straight out of your book, that's the pictures, so if you want to look that up, it's on page 249, so feel free if you want to follow along that way. But pretty much we're studying about two different special cases of problems where two variables vary directly with each other or where they vary inversely with each other. And what that means, if it talks about varies directly or is directly proportional to, means that A is equal to some number times B. So A is equal to some number times B. That's what it means to vary directly or directly proportional to. If we say inversely, A varies inversely as B, or A is inversely proportional to B, we say A is equal to K divided by B, again where K is some number, and then B is the other variable. So K is a number. We're talking about direct variation. Both of these are in the numerator. We're talking about inverse variation. One's in the numerator, one's in the denominator. So let's just read a couple here. It says, the number of boys varies directly as the number of girls. So it varies directly, so the boys is equal to some number times girls. The price varies inversely as the number. So price is equal to K over N, a number. The resistance is directly proportional to the length. So R is, right, that's the equal sign, some number times L, the length. The number of revolutions per minute is inversely proportional to the number of teeth. So the RPM, this is one variable, is directly proportional to K over N, the number of teeth. The water produced varies directly as the amount of hydrogen burned. So W is equal to K times H. Okay, so what we're going to do is we're going to work a couple problems with this. And the main thing we really have to do is be able to convert this into this, and then we can plug in information that they give in addition to this to then solve the problem. Alright, so this is practice A and practice B. Practice A says, the number of bluebirds in every tree in the grove varies directly as the number of redbirds. In one tree, there is 12 bluebirds and 3 redbirds. If in another tree, there are 6 redbirds, how many bluebirds were in the tree? So first of all, let's talk about this right here. It says the number of bluebirds varies directly as the number of redbirds. So I'm going to use a capital B for bluebirds and a capital R for redbirds. So it says bluebirds in every tree in the grove varies directly. So it's going to be some number times R. Okay, so now we have an equation with 3 things that we don't know. Number of bluebirds, the K, the constant, and R, the number of redbirds. Then it gives us one situation here. It says in one tree there are 12 bluebirds and 3 redbirds. So in some situation, I know the B is equal to 12 when R is equal to 3. So using this information, I can solve for K. So I'm going to plug this in up here and this in up here. So 12 is equal to K times 3. Dividing both sides by 3, I get K is equal to 4. So now I have my direct variation equation. B is equal to 4R. And now I can use that to work with this last part. It says if in another tree there were 6 redbirds, so that means R is equal to 6. How many bluebirds were in the tree? So I'm looking for number of bluebirds. Well, I can plug this in up here and I can solve for B. So B is equal to 4 times 6 because it's the number of redbirds. So that means I could say the number of bluebirds is going to be 24. So I'd say 24 bluebirds. Okay, same basic principle on this, except for our original equation starts off a little different. It says the number of revolutions per minute, or RPMs, varies inversely as the number of teeth in the gear. If 60 teeth result in 150 RPMs, what would be the RPMs if the gear had 100 teeth? So let's look at this first part right here. The number of revolutions per minute varies inversely as the number of teeth in the gear. So I'm going to use capital R for the revolutions and a capital T for the number of teeth. So the revolutions varies inversely, so it's going to be K as the number of teeth, Then let's look at this. It says if 60 teeth result in 150, so that means T is equal to 60 when R is equal to 150. So what we can do now is we can solve this. So we can plug that in there, so I can say 150 is equal to K over 60. Solve for K, I'm going to multiply by 60. And I get K is equal to 9,000. Now I have my particular inverse variation problem. So I can say the revolutions per minute is equal to 9,000 divided by the number of teeth. Now we can look here at this last part. What would be the RPM? So I'm looking for that if the gear had 100 teeth. So now the teeth is equal to 100. What is the RPMs? So then R is equal to 9,000 divided by 100. So that means my RPMs is going to be 90. So I'm going to say 90 revolutions per minute. Feel free to watch this again if you need. Your homework is there on page 250. The only ones you have to do is 1 through 4, and then you can pick 11 more of your choice. Good luck.